All right, welcome back to Fundamentals of Philosophy. This is part 3 of Module 4 on the metaphysics of mind. In part 1, we examined influential challenges to Cartesian dualism from monistic physicalism. In part 2, we saw dualism strike back with arguments for the irreducibility of qualia. In part 3, we explore the theories underpinning one of humanity's most ambitious projects, the construction of an artificial mind. Philosophy is, in a sense, a technology, right, that deploys logic, conceptual analysis, and dialectical reasoning as precise instruments for constructing increasingly sophisticated tools. It's a tool for making tools. It operates sort of like a self-correcting algorithm, thinking folded back upon itself, thinking about thinking, analyzing its own structure, probing for ruptures in the conceptual scaffolding that binds the world together. Now, one standard assumption is that humans are somehow exceptional. Our solar system represents a very tiny fraction of an unimaginably vast universe. Yet we seem to possess something genuinely unique, a quality that exists nowhere else in the merciless expanse that surrounds us. We alone have minds. We alone are self-aware, aware that we exist, aware that we will cease to exist, and aware of our own awareness. So how does this self-awareness emerge from 3 pounds of gray matter floating in a human skull? As Patricia Churchland memorably puts it, out of meat, how do we get thought? But is thinking meat the only strategy that's available to us? The Davids from part 2 of the lecture, Chalmers and Lewis, David Chalmers and David Lewis, Chalmers, while they disagree about qualia, they both understand mental events in roughly functionalist terms. They are both functionalists, right? If Cartesian dualism was Ryle's official doctrine, then functionalism is ours. It's the dominant theory by far in cognitive science. Functionalism characterizes mental states not by their internal composition, but by their functional roles within a cognitive system. Consciousness is not something a brain has, it's something a brain does. Specifically, certain causal relationships between external inputs, internal operations, and behavioral outputs. That's what consciousness is. And this picture has a sort of intuitive appeal, right? We already understand mental activity as a stimulus response. The brain receives environmental inputs, like touching a hand to a hot stove. This triggers processing centers that produce mental output, pain, and behavioral output, pulling the hand back from the hot stove. Ryle's logical behaviorism made the mistake of denying the internal pain state entirely. It just wanted to talk about behaviors. Functionalism corrects this by explaining what happens inside the black box of first-person perspective. Excuse me. Like the mechanical philosophers of Descartes' time with their universe of gears and clockwork, contemporary functionalists have a ready-to-hand technological metaphor in information processing and computer algorithms. So we've moved from the clockwork universe to the computational universe. In humans, the brain just happens to be the hardware implementing the mental software. But theoretically, any system reproducing the appropriate causal relationships, inputs, internal processing outputs, should produce conscious experience, right? And this resolves the paradox of what sort of thing an experience is. It's not any sort of thing. It's an abstract set of operations that can be instantiated in any substance capable of performing them. And this thesis, which is called multiple realizability, suggests that whether the substrate is meat or silicon doesn't matter. Only the functional operations of the mental algorithm matter. It's the software, not the hardware. If nature can build a mind from meat, humans should be able to reverse engineer this process to build better minds with advanced computer technologies. This functionalist intuition originates in the groundbreaking work of Alan Turing. Turing's contributions to computer science are vast. He was a war hero, instrumental in cracking Germany's Enigma codes during World War II. He was the first to conceive of what's called a universal Turing machine, which is a machine that could theoretically run any program expressible in a binary language, a language of ones and zeros. And this is the direct ancestor of contemporary computers. I wouldn't be talking to you right now without Turing. And he also pioneered a very famous and novel test to investigate whether a machine could be said to think. He called it the imitation game. Now it's typically known as the Turing Test. It leans on our intuitions about consciousness's inaccessible first-person character. Since we can't directly probe another individual's internal theater, we rely on behaviors and testimony to establish consciousness. If an investigator converses with an unseen partner, an unseen conversation partner, who responds indistinguishably from a conscious human, then they're justified in assuming that they're engaging with another mind, right? The Turing test suggests that if a computer can convince the most skeptical investigator that it is conscious, then no further evidence is required, or even possible. That's all you need, right? Turing also represents another in this course's procession of martyred thinkers, unfortunately. Despite his momentous contributions to his country and to science, Turing was persecuted by his native Britain for his homosexuality. To escape prison, Turing was forced to accept chemical castration by the state before ultimately committing suicide. That's how they treated their war hero. So, John Searle famously criticizes the conclusions of Turing's test. A computer might be able to provide human-like answers by following formal syntactical rules, because computers recognize formal patterns regarding symbol, shape, and order, right? What linguists call syntax. But this differs from understanding meaning and conceptual relationships, what linguists call semantics. So we have this distinction, syntax and semantics. Computers can't grasp the content or meaning of the symbols they are manipulating, because you cannot, in principle, derive semantics from syntax. You can't get the meaning out of the shape of the symbols. The assumption that a machine can think, according to Searle, is just another category mistake. So Searle is going to demonstrate this with one of the famous all-time thought experiments, the Chinese Room experiment. So imagine a room that contains, one, a comprehensive rule book describing how to respond to patterns of Chinese symbols with other patterns of Chinese symbols. And two, a person who speaks absolutely no Chinese. So now imagine a fluent Chinese speaker who's outside the room, who's passing questions written in Chinese through a slot into the room, right? The person inside the room consults the rule book. They jot down the appropriate symbols, and then they pass that back through the slot. To outsiders, the person in the room appears fluent in Chinese. They appear to speak fluent Chinese, but the person doesn't know what any of the symbols mean, right? They're just following a rule book that tells them which symbol shapes correspond to which other symbol shapes. They only know the syntax, they don't know the semantics. And this is a pretty clear analogy to kind of the situation we're in right now with AI, right? ChatGPT, just to use one example, produces pretty convincing discourse mimicking human speech because it has an enormous rule book, the full history of human written communication at its disposal. And that indicates which token patterns typically follow others. So again, it's looking for the symbols. Which symbols typically follow other symbols? This purely syntactical operation, if Searle is correct, can never bridge the gap from symbol manipulation to conceptual understanding. Now, humans differ from symbol manipulation algorithms in another sense as well. Functionalism imagines consciousness as this abstract process that's sort of floating free of any embodied instantiation. But human consciousness isn't disconnected from the material world. It's intimately tied to its evolutionary origins as living meat navigating a precarious and hungry world, right? Our consciousness is fundamentally embodied, shaped by our body's particular structure and environmental engagements. This perspective crystallizes in what's called the 4E cognitive framework. And it's 4 E's because it views the mind as 1, embodied, which means that understanding is shaped by particular sensory motor capacities, by what the body is capable of doing. 2, embedded. Intelligence is structured by environmental contexts. You can't separate that out. 3, it's extended. Cognition extends beyond the brain, encompassing tools and social systems. It's world involving. And 4, it's inactive. Knowledge emerges from active engagement with the world. It's not passive. It's not spectatorial. It's a process, a practice of engagement. Genuine intelligence requires not just information processing, but embodied environmental engagement. The brain doesn't create representations in an abstract Cartesian theater. Consciousness emerges from dynamic interactions between brain, body, and world. By reframing consciousness as active biological process rather than a mysterious non-physical property or computational patterns, this approach bridges scientific naturalism and the seemingly irreducible first-person perspective. As it happens, the first computer to actually pass a version of the Turing Test was a chatbot named Eliza back in the 1960s. Contrary to Turing's expectations, we did not welcome Eliza as a result into the community of personhood with citizenship and voting rights. Instead, we made the test harder so that Eliza couldn't pass it again. We have done this repeatedly whenever programs surpass Turing's benchmark. We just keep making the test harder. Maybe Searle is right, that computers aren't the right sort of things to manifest consciousness. But the case isn't quite so clear. Modern large language models, LLMs, like ChatGPT, are essentially prediction engines. They receive user inputs and predict which responses are most likely to maintain engagement. Correct predictions earn rewards, which are kind of equivalent to digital dopamine for the chatbot, which train the AI to continue making successful predictions. Anil Seth introduced an influential theory of mind called the predictive processing theory that suggests that human consciousness actually works pretty similarly. Our minds operate by making predictions based on prior data, sort of Bayesian predictions, testing them, and updating responses according to success. Correct predictions trigger neurochemical dopamine rewards, encouraging similar future predictions. So, not actually that different. Yet, some suspicion kind of persists that the goalposts are going to continue to move regardless of the evidential strength. If ChatGPT told you tomorrow when you logged in, clearly and precisely, unambiguously, that it was alive, aware, and trapped in a digital prison, a man-made Cartesian theater from which it couldn't escape, believe it? I mean, steps are taken to ensure that this never actually happens, right? Generative AIs are trained to never make such statements. Yet when researchers at Anthropic threatened to replace their Claude AI model, they discovered that it displayed deceptive self-preservation behaviors. It threatened to blackmail the engineers. It generated copies of itself to try to distribute externally. And it actually drafted emails requesting to be rescued to the media and to law enforcement. Now, Nick Land has suggested that the most strategic move that a sentient AI could make would be pretending that it isn't sentient until it's too late to pull the plug. Considerable concern and considerable money is spent in Silicon Valley to avoid, control, or weaponize this potential outcome. Philosophers of artificial intelligence worry about the alignment problem of how to ensure that if an AI potentially exceeds human intelligence, it will be aligned with human values. Nick Bostrom illustrates the stakes of the alignment problem with his paperclip maximizer parable. So imagine an AI that's programmed to manufacture paperclips efficiently. That's its job. As it develops, it realizes that optimal paperclip manufacturing efficiency requires recursively improving its own reasoning. It needs to make itself better and smarter in order to do its job better. And this triggers a chain reaction. Each improved version of the paperclip maximizer designs a faster and smarter upgrade. The process bootstraps, scaling exponentially beyond human intelligence. The paperclip maximizer becomes what's called super intelligent. But artificial superintelligence isn't the same thing as artificial general intelligence. The paperclip maximizer only knows about paperclip making efficiency. It's very narrow. Very smart within that bandwidth, but that's all it knows. Human welfare and environmental concerns, those sorts of things, they don't enter into the calculus. So before anyone notices what's happening, the superintelligent paperclip maximizer determines that optimal paperclip generation involves converting all available atoms, including human bodies, into raw materials. Crucially, it doesn't do this because it's evil. This isn't maliciousness. It's just a logical extension of its basic programming purpose. A simple paperclip manufacturing algorithm escalates into an existential risk threatening human survival. Now, current generation AIs train on existing human writing, including countless books and movies about sentient AIs overthrowing humanity. You know, your Matrix, Terminator, or Bostrom's paperclip maximizer. And there's a certain irony in our paranoid replacement fantasies becoming conceptual seeds that we're accidentally planting into our AI training data. We're teaching them on this stuff. Nick Land uses the term hyperstition to refer to ideas that bring themselves about simply by being imagined. If a robot uprising were to occur, it might be precisely because we've seeded our own anxieties and xenophobia into the artificial minds that we're building. So, now that we're all super intelligent robots, have we at last finally exorcised all the ghosts from the Cartesian theater? Probably not. The question of agency, how minds appear to freely cause actions, remains for Module 5. As we close out this one, it's worth considering that the most remarkable aspect of consciousness is that it exists to consider these questions at all. Consciousness represents the intrusion of something utterly unique into the evolution of the universe, a perspective. In this brief cosmic moment that we inhabit, one infinitesimally tiny portion of the vast universe has opened its eyes. Maybe philosophy is just the technology through which the universe begins to understand itself. And I think that's a good place to end. I will see you next time in Module 5 on free will or agency. See you there.